Hello, this is Martha from the Academic Support Center once again. We're going to do some Calc 1 today, and this is just a short video going over two examples of finding limits analytically. Alright, so our first example is the limit as x approaches 3 of 2x minus 5x all over x minus 3. Now, if we put that in, we're going to have a 0 in our denominator, which is undefined. So we have an asymptote where x equals 3. And so what we want to do is we want to break it into a dual-sided limit and see what's going on. So we're going to take the limit as x approaches 3 from the left, so something a little smaller on the number line or left on the number line, and the limit as x approaches 3 from the right. And so let's put this in and see what we get. We get 2 minus something that's close to 3 is 2.9. So 5 times 2.9 all over 2.9 minus 3. Now, we could go put this all in the calculator, and we will. But let's say if 5 times, almost 3, that's almost 15. 2 minus 15, so upstairs is going to be negative. Now, 2.9 minus 3 is also negative. So negative over negative means that this is going to be positive infinity. Let's double check our work. And we'll put into the calculator 2 minus 5 times 2.9 is negative 12.5 divided by negative 0.1. And we get that that is positive 125. So as the graph approaches this asymptote, whatever it does is it's going up to positive infinity. Now let's switch over and see what it's doing as the limit approaches 3 from the right. So the limit as x approaches 3 from the right. So something a little bit bigger. So we've got 2 minus 5 times, let's do 3.1. That's a little bit bigger. All over 3.1 minus 3. Now up top, we're going to have 2 minus something a little greater than 15, which is going to give us a negative. And down here, we've got 3.1 minus 3, which is going to give us a positive. So we know that it's going to be going down or negative overall. But let's just double check this. We've got 2 minus 5 times 3.1. And that gives us a negative 13.5 in the denominator. And 3.1 minus 3 is just 0.1. And that gives us a negative 135. And so we know that whatever's happening, the values are going down to infinity as we get closer and closer to 3 from the right. As we go from the left, we're getting closer and closer to, it's going up and up as we get closer and closer. So we do not have a dual-sided limit here, so the limit does not exist. And this was a way to find analytically. We looked at, okay, well, we can't use direct substitution, we can't really use factoring or some of our other strategies, but let's pick in numbers on the number line that are a little higher or a little lower to kind of see what's going on around it. So our next problem is a little bit more exciting, and let's move on. All right, on to example number 2. Doesn't this look like fun? We've got the limit as x approaches negative 4 of negative x cubed plus 5x squared minus 6x, and then all over negative x cubed minus 4x squared. All right, so what can we do? Let's see if we can't make our life a little simpler by factoring. Up top, we can factor out a negative x, because I like to start on a positive note, and down below, negative x squared. So if we factor out a negative x from each term up top, we take that out. A negative x cubed divided by negative x leaves us with x squared. 5x squared divided by negative x leaves us with minus 5x. And negative 6x divided by negative 6 leaves us with plus 6. Okay, and we can't forget the limit as x approaches negative 4. Can't forget what we're doing. Now down below we can take out a negative x squared from each term. So we get negative x squared. If we factor that out from negative x cubed, that just leaves us with x. And negative 4x squared divided by negative x squared leaves us with plus 4. Alright, so now we can do a little bit of canceling out here. The negatives cancel to positives, and this x cancels out. We're just left with one x down below. Now let's see, what can we multiply to get to positive 6 but adds up to negative 5? So we're going to do 1 and 6, negative 1, negative 6, 2, 3, negative 2, negative 3. Those are kind of the factors that get us to positive 6. If we add them together, 1 plus 6 is 7, and that's not our middle term. Negative 1 minus 6 is negative 7, that's not our middle term. 2 plus 3 is 5, not quite. Minus 2 minus 3 is negative 5, so that's how we know how to split up our terms. So what we're left with is we've got, up top, we've got x minus 3 times x minus 2 all over x times the quantity x plus 4. Oop, can't forget the limit, carry that down. So if we put in negative 4, we're going to have a 0 in the denominator, which gives us undefined. So we're going to go ahead and draw our number line up here. And we're just going to look at negative 4 because that's what we've been asked to analyze. And we've got an asymptote, a vertical asymptote here. So let's draw it in. And what we're going to do the same thing we did before, where we're going to take the limit as x approaches negative 4 from the left, and then we're going to look at the limit as x approaches negative 4 from the right. And having this factored form over here will make it nice and easy to do that. So let's choose something a little bit larger than negative 4, or a little bit to the left. So let's do negative 5, make our life a little easier. And what we're going to do is we're going to put negative 5 in for x. So negative 5 minus 3 times the quantity negative 5 minus 2 all over negative 5 and times negative 5 plus 4. And really what we're looking for, because the limits that we're dealing with are going to infinity, we want to look and see if it's positive or negative. So let's take negative 5 minus 3 gives us negative 7, or negative 8, there we go. And negative 5 minus 2 gives us negative 7. So up here we're going to have a positive, because a negative times a negative is a positive. And down below we've got negative 5 times negative 5 plus 4 gives us negative 1. So that goes to positive as well. So we know that as we approach from the left, it goes up to positive infinity. Now let's see what happens as we approach from the right. Let's choose something, 0 doesn't work, but let's choose negative 3. We're going to put negative 3 in for x, and then look and see if the answer that we get, is it positive or negative. So we've got negative 3 minus 3 times negative 3 minus 2 all over negative 3 times negative 3 plus 4. And we're going to do like we did before and work our way up. So this comes to negative 3 minus 3 is negative 6 times negative 3 minus 2, which is negative 5, and that gives us a positive 30, but a positive. Now down below we've got negative 3. Negative 3 plus 4 is 1, and that's a positive, which gives us negative down below. A positive over a negative means that it's negative infinity, so infinitely going down. So it is there are one-sided limits, but because we have as we approach from the left, it goes to positive infinity, and as we go to the approach from the right, it goes down to negative infinity. So this limit The two-sided limit does not exist. All right, I hope this has been helpful. Let us know if there are more examples you want to see. Have a great day.